concepts on what a pure substance is, what a compound is, and what a mixture is. So we're going to play a game called, but first, elements, compounds, or mixtures. So, first one here, what does this show? And you guys can all just shout this out right now. Is this an element, compound, or mixture? All right, awesome. Hopefully you all said that was a mixture. Notice you don't see the same particles. You actually see particles mixed inside here. You've got some of the green ones, you've got some of the pink ones. So that's going to be a mixture. What about the next one? Is this a element, a compound, or a mixture? Just shout it out what you think it is. All right, awesome. Hopefully you said that was a compound. Notice it can't be an element because it's not made up of all the same stuff, but the particles are the same. They're made of one blue and one red, so they are all the same, but they're made up of different elements or different atoms, so they are actually a compound. Okay, what about the next one here? Shout it out, remember. What do you think? Element, compound, or mixture? Okay, hopefully you all said that's a mixture as well. So notice you've got the blue and reds, that's a compound. You've got the purples, those look to be like elements. So if they're mixed up together and they're not all bonded chemically to each other, that's going to be a mixture. Next one. Yell it out, people. All right, of course that's an element. Notice it's all the exact same type of atom. It's all the same type of particle. There's no mixing of anything else in there, so it's a pure substance. It's an element. Next. What do you think this one's going to be? Yell it out. All right, of course that's going to be a mixture. Notice you've got different compounds there, and they're all mixed together. So they're not all chemically joined. They're not all the same particle, so it's not a pure substance. It is a mixture. Next one. What do you think? Yell it out. Okay, awesome. You should have said element. If you did, that's great. They're all the same, even though they're chemically joined together. All right, so now, good job on that. Let's move on to the periodic table of elements. We're going to go through this in just a few minutes, and then you'll be able to get started on learning the actual elements. So some of them, the elements, chlorine, nitrogen, helium, mercury, sodium, silver, phosphorus, gold, carbon, oxygen, lead, hydrogen. Some of these you've probably heard of before, and these are all actually elements on the periodic table. So what is an element, though? Now, scientists have actually identified about 118 elements, some that are naturally occurring that they find in nature, and some that have been created in a lab. And actually, number 118 has actually been very recently added and discovered in a lab. Okay, now the elements alone, or in combinations like in compounds, they make up our bodies. So our human bodies, we are made up of completely elements. So there are nothing else to our body except these elements that are found on the periodic table. So they make up our bodies, they make up our world, our sun, and in fact the entire universe. So that galaxy that you see right up there in this picture, that's actually made of the same type of elements that are inside our bodies sometimes. It's kind of cool to think about. All right, so let's have a look at some information about the periodic table. The first thing is the periodic table just organizes the elements in a particular way. Now we're going to be going over that a little bit more in depth tomorrow or next class. So from the periodic table we can gather information about the element based on where it's located in the periodic table. And then we can actually predict the physical and chemical properties of an element. So remember, we've talked about physical and chemical properties. We can actually predict what those are going to be just based on where it is in the table. So it's actually a pretty powerful tool. Now, one thing that the table is set up, like if you see this, it actually separates different states of the, not different states, sorry, but different types of atoms or elements in the periodic table. You end up having the green ones. Those are going to be non-metals. So those can be things like gases, like powders, but they're not metals. But all the blue ones here, those are all metals. And then the pink ones here, those are called metalloids, and they have properties of, some properties of metals and some properties of non-metals. And we'll be talking a little bit more about that next class as well. Okay, so let's talk about what the chemical symbols or element symbols actually look like. So the symbols, first of all, every single element has their own unique symbol. That's so that we don't confuse them. Now those symbols can consist of a single capital letter or a capital letter and one or two lowercase letters. Now most of them have two letters. One's a capital, one's a lowercase, and we'll show that. There's only a few that have two lowercase letters after the capital. Okay, most symbols contain the starting letters or letters from the English element name. However, some of them are going to be derived from their Greek or Latin names. So I'll give you a few examples here. If we're talking about carbon or oxygen, very simply, carbon is represented by the capital letter C, oxygen is represented by the capital letter O. However, when we talk about bromine, you might think it's going to be represented by the capital letter B, but it's actually going to be represented by BR. So it's a capital B, a lowercase r. And so all of these have been easy to predict so far. Carbon C, oxygen O, bromine BR, but sodium is going to be a little bit different. Sodium's not going to be SO, because it's going to be derived from either the Greek or Latin, so you're going to have to know this one, and sodium is actually represented by Na. All right, so who discovered the periodic table, or who kind of made it up? So this guy named Dmitry Mendeleev in 1869, Mendeleev created the first accepted version of the periodic table. And what he did was he just grouped elements according to their atomic mass, and when he did that, he found that certain elements had similar chemical properties. And that's why he grouped those together so that we can now predict what their properties are on the periodic table. Okay, the thing is though, based on the, sorry about that, my dog is a little loud. Based on the time, he didn't have the technology to find all of the elements. So what he did was he left blank spaces open so that as time went on and as more elements were discovered, they would be able to fill in the gaps. Okay, so this is that crazy looking, oh, let me see that again. Ooh, yeah, that's crazy looking Mendeleev. He didn't even want to stay on the page for a long time. Okay, so anyways, that's Dmitry Mendeleev. That's the periodic table. Just a quick intro to it. We'll be looking at it a little bit more in depth next class. But as for what you're responsible for in terms of this periodic table, you are responsible for knowing the first 20. You need to know their element symbol, and you need to know the spelling of the element, and a few others. So I'll be telling you what those few others are later on, but you do need to know the first 20. So starting up here with H and going across to HE, then LIBE, BCNOFNE, and then all these down that row, all the way up to CA, which is over here. Okay. You need to know the first 20. Some other ones you might need to know, and I'll be telling you this later on a little bit, something like Fe, which is iron, Ni is nickel, Zn is zinc, and so on. Okay, so hopefully you enjoyed this video, and you learned a little bit about what the periodic table of elements is.